All right, everybody, we're gonna start. That's cool. Thanks. Throwing you a curveball. Team 6 is going today. We trade with Team 2. We're gonna be talking about charging batteries with solar cells, and I'm Danny.
I'm Alan.
Leon.
I'm Tip.
Today I'm going to talk about how to assemble a solar panel from the solar cells. This is the solar cells that is part of our project because our sponsor wants us to build a smaller version of the solar panel, and that is not available on the market. So we just decided to build our own. And we got these 6x6-inch solar cells, and they're rated 0.55 volts, and the maximum open circuit current is maximum circuit current is about 8 amps. And so the basic layout of this the solar cell is this side, the blue side, which is face to the sun, is the positive side and has 2 stripes. So basically, all the current will go to these 2 stripes, and you will solder some wires on it. It's called the tag wire, which I'll explain later how to solder it and what it looks like. Our design needs 12 volts output. So basically, we need about 25 pieces of solar cells because you want the voltage to be higher, so that you get a higher voltage than battery, so that battery can be charged. So there are some good things and bad things if you build your own solar panel. So the good advantage is it's a lot cheaper than buying the solar panel from a distributor, and also the output voltage and current you can control it depending on how you want to connect the solar cells. You can build like really high voltage, or really you have a lot of current from it. And also you can, for this project, we can vary our size to fit like depending on the location you want to put solar panels. And also the bad things about building your own is the process building the solar panel is extremely time consuming. And also solar cells are really hard to work with because they're really thin. The thickness is really less than 1 millimeter, and it's really fragile. It's like a piece of glass, but only really softer. So here are the parts and tools you're gonna need for soldering the solar cells. And so this is the back side of the solar cell. This is the negative side. So the first thing you need is the flux pen, and the flux pen is you apply it to the 2 stripes before you solder the flux wire on it. It will increase conductivity, and also because when you heat a piece of semiconductor for too long, it's going to degrade. So the current output from it is going to reduce. Therefore, the efficiency of the solar panel will also reduce. And also, the flux pen will help you to solder the flux wire on it. So this is the tag wire, also known as the flux wire. It's really a really thin, wide wire that is, you can just, it has solder on it, so you don't need to put any solder on it. You just heat it up and it will just solder on the solar cell. And also, the rubber gloves are recommended because you will get a flux pen, the ink on it, and if you put your finger has some oil, if you just spread it all over the solar cell, it's gonna mess up the component. So this is the overall layout when the product is finished. So it's basically like our last presentation. There's several solar cells we're going to build, and then a charging controller, and finally to the batteries. It's the whole system.
It is very important to pick the size of your solar panels, because you have to consider the power you need and the solar panel's output power. And usually when the solar panel is rated over 5 watts, it is suggested to have a microcontroller. The solar charging controller. Why is that? Because it prevents the overcharging the batteries. It will shut off the charging, and it will increase the efficiency of the charging by using the maximum power point tracking system. And it will prevent the battery discharge while the sunlight is low. The charging time, usually the deep cycle battery is around 60 to 112, 120 volt amp hour. And for our example, we use 90 watts and 12 volt and 7.5 amp for the solar panel. So the charge time you can see is 8 hours for a fully charged battery. But if you double the batteries, you'll also double the charging time. And you double the solar panel, it will decrease the charging time by half. And for the maximum power tracking system is to optimize the power transfer from the solar panel to the batteries. And here is an example of what it does. Generally a solar panel that's rated 12 volt, it will usually output 16 or 17 volts. And the maximum power tracking system will convert the 17.6 volt to 12 volt to match the batteries. But instead of charging the battery with 7.4 amp, it will increase the amp to 10.8. That will still also be 130 watts. So if you charge the battery with original amperage, you will lose 41 watts. And when are you using this MPPT? Is when you try to maximize the power transfer. Here are 3 conditions that can be used. The cold weather. Cold weather usually means the low sunlight, you say. So that's when you definitely need to maximize the power transfer. And low battery charge and long wire for preventing loss.
Alright, so the solar panels don't give you a constant power output, as you were just talking about. You can have a variable amount of amperage coming out of them based on the weather. So the best choice to store the energy are deep cycle batteries. Deep cycle batteries are the best for a variety of reasons. The biggest one for us is that they're cheap, and you get a lot of stored amp hours for the price, and it's a very big consideration for a design in India because cost is a big factor. They're also easily available around the world, so you can go get them at any local hardware store here. We're expecting the same in India from our sources, what they've told us. The most desirable characteristic of deep cycle batteries, though, is that they're designed to be discharged regularly. Unlike other lead acid batteries that are for like starting currents, they're meant to provide large instantaneous currents, whereas deep cycles have thicker charge plates, so in turn they last longer, but they provide smaller currents, which is what we're looking for a constant load. Since they're cheap and easy to handle, it also makes it very easy to create battery banks and expand the capacity of the system. Right here is a graph showing the charging of a typical lead acid battery, whether it be automotive or deep cycle. All the charging controllers follow the same process. It's 3 stages. The first stage, stage 1, is what they call the bulk stage. It's basically where they're just dumping current into the battery, and they're doing this to charge it as quickly as possible. So you can see the dotted line is the current flowing into the battery. The solid line is the voltage per cell. 6 cells make a 12-volt battery. Once all that current dumps in and it's getting closer, around 80% to the full charge, the current will slowly start to decrease, and this is stage 2, called the topping charge. What it does is the current slowly decreases as the voltage is closer and closer to a full charge. And then it'll finally get around 98, 99% of the full charge. And then it just starts a trickle charge phase, which basically just keeps the battery from discharging itself. So, just sitting there, it'll gradually lose some charge, and it just provides it enough to stay constant. So this is what our charging controller in a solar circuit is going to do for us, but it's the basic same process for charging a car battery or anything like that nature. Like I said, it's easy to increase the charge capacity of a system, and you can do this just by adding batteries in parallel. As long as, it's very important to note that all the cells are at the same voltage, because otherwise adding them in parallel, you're going to have a problem with Kirchhoff's laws. And the one flip side to adding all the batteries in parallel is that it can complicate the charging.
Okay, so now we're just doing like a simple like explanation. As you can see, you've got the solar panel on the left-hand side and the battery on the right-hand side. There's only one current loop right now with one battery, so all the current that comes out of the solar panel goes into the battery. Now, and here's when you're charging multiple batteries. Now, the reason you want to choose to charge batteries in parallel rather than in series is that if you put all of them in series, 4 12-volt batteries in series is 48 volts, and that means you need a much larger solar panel, and you need to configure it for variable voltage if you're going to add or remove batteries in series. And that's just too much difficulty. So when you put them all in parallel, everything's the same voltage as long as all of the batteries are the same voltage. So you've got the current splitting up into all the different batteries. Now, unfortunately, that means all the batteries are going to charge more slowly because the current coming from the solar panel is still going to be the same, but each battery only gets a certain amount of current. Now, kind of like the limitations of this is that what we described in this presentation is mostly used for small-scale projects. It is feasible for larger-scale projects, but there are much better alternatives out there because if you try to scale this up, you'll need a lot more solar panels to deal with increased load. Now these two are kind of like more extreme examples of connecting all these batteries up, and these are more like just battery banks for larger scale applications. And if you're going to do something like this, you're also going to need a thicker wire, so lower gauge wire, to deal with all of the extra current that will be coming in.
Any questions? Yeah.
How many solar panels have you broken so far?
I've broken at least one myself.
Yeah.
They're very thin. When I opened them up, they reminded me of, you guys remember like the holographic Pokemon cards? They're about the same thickness too. Yeah.
So, what's the system voltage of your solar panels again?
Solar panels, we haven't built them yet, so I mean, I can't give you we're aiming for around 14 volts, so just enough so that the charging controller can take the extra voltage and convert it to the 12 volts.
Each cell is about a half a volt.
Have you guys considered maybe doing series batteries, like you said, and then using a boost controller, so that way a boost power point tracker? That way you'll always be tracking. Because if you have a solar cell that goes, let's say, partially in the sun, the voltage is going to drop to like, let's say, 6 volts. You can't charge at that point.
For our specific design, the main reason we went this route was because if we went with the boost on that side, we were going to have to step down to go to the computers, and we found it a lot easier to just get boost converters for the computers versus step down there. And
Okay,
vice
so
versa.
there's
Yeah, there are
makes
other
sense.
considerations. Anyone else?
This is not very technical, but how sensitive would these panels be to, say, dust and other, and how we going to keep it clean off from the surface?
Well, we just want you to build a frame that just use glass because I think that's the only material is available to us. And the only thing, I know that the solar panels are really sensitive. You just put your hand on it and its power output is just going to decrease. So basically, the only thing we can do right now is just to keep it clean and to seal the inside really good so that no dust will go in there.
We've also been communicating with our sponsor because this was kind of his idea altogether, was to build them because he can more easily transport them to India this way. And he's also going to have to build a lot more, so we're kind of experimenting with him to see what he prefers in the construction and what he feels comfortable with. So that's the stage we're in right now. We're thinking plexiglass on the front and then some sort of